Welcome to the Middle Room Workshop. Today I'm going to show you part 5 of this series of in-depth video tutorials about LaserGRBL. In today's video I'm going to talk about custom buttons and settings. Without further ado, let's get into it. In part 1 through 4 of this series of video tutorials about LaserGRBL, I've been covering pretty much everything that you need in order to work with the software. In particular, I've been showing you how to work with all of the files currently supported by the software, namely G-codes, raster images, and SVGs. Today, I'm going to concentrate in more advanced features that you might need along the way, among which I'm going to show you custom buttons, what are they and how to work with them, as well as some of the most important software settings and machine settings through the GRBL configuration window. Alright, so if you're looking at my interface right now, I'm sure that many of you are wondering why my interface looks different, and you would be perfectly right. In fact, on the bottom portion of the screen you will see that I have a bunch of buttons that are most probably not available within your interface. Now, these are actually custom buttons. LaserGRBL gives you the opportunity to create custom buttons which add functionalities to your software. Now, custom buttons allow you to basically perform certain actions or operation before or while a project is being engraved. Now, when you first install the software comes with built-in custom buttons or preset custom buttons, and these are going from the center buttons over here all the way to the blink. So everything else that you see after that, it's basically custom button. Now, this button was downloaded from LaserGRBL website as well. This is my own custom buttons, and then the remainings are basically part of Aufero custom button set, which allows you to work with their machine even if I'm not using them particularly. Now, you should already be familiar by now about what these custom buttons are doing over here. For example, you're using the framing button when you want to see where your project is going to be engraved, or for example you're using the focus button in order to brighten up a little bit the laser so that it's easier to see through safety goggles and gives you the opportunity to do the focus, and then when you click back on it, it's basically powering that down, or the blink just to see instantaneously where the laser falls. And so you can basically edit those buttons and you can add also additional functionalities. Now, if you right click on any one of those buttons, you have the option to remove the button or to edit the button. So let's see edit button. This will launch basically a custom button editing pop-up window. Now, before getting any further, let me tell you that LaserGRBL has 3 different type of buttons. As you can see over here, on the top you have type, and then you have this drop down. You can see you have a button, a two-state button, and a push button. And I will explain you this with some example. Now, a button is simply a button that when clicked, it's executing a block of code, which you can see over here. And then once it's done with that, that's all about it. And so this is, for example, the case for the framing button, because you want, when you click the machine, to basically frame your project in the working area, and then that's pretty much all, just to go back and that's it. Other buttons, like for example the focus button, if we go into the edit, you see this is a two-state button, and that's because you want the laser to be slightly brightened when you click it the first time, and then when you click it the second time, you want the laser to go back to its original power or brightness. In fact, you can see when I click, it goes on, and then if I click again, it goes off. Blink instead is a push type, so this is basically executing a block of code as long as you hold down the left key, the left mouse, and when you release the left click, it's basically executing another code, which in this specific case is basically turning off the laser or putting it back to the original condition. Now you have the option to, if you click over here anywhere on this custom buttons area, you have the option to import, export another button, as well as you can basically lock the position. So if I untoggle this, I'm basically able to change the position of the buttons the way I like, and then I can toggle that back on and I cannot move them anymore. Then you have the option to export them, so you can basically save the set of buttons that you currently have on the screen, or you can import. Okay, so for example, I'll show you. There we go, LaserGRBL. I have custom buttons from Aufero, which is the set which is over here. So I could click on it and then to follow the window which will guide me on setting them up. So I won't do that. And then the other option is to add the custom buttons. Now, let me remove this so I can show you how to put that back. Remove button. Are you sure? Yes. Give us one sec. Now, setting up a custom button is actually fairly simple. And to do that, we can go into one of the existing buttons and we can basically copy and paste the block of code that is already in there and to edit upon that. And so if we want to perform something that is similar to what is already available, we can do that very easily. If you want to do something that is completely custom, then you will need to learn a little bit of the syntax. Now the syntax is actually fairly simple. This is using a G code, as you can see over here, G0, M3, G1, M5, and so on. And by the way, if you're interested to know more about G code, I have a video about G code, so I'll highly recommend you to look at that. And then over here on the right part, as you can see, we have this axis with square brackets. So X, Y with square brackets. This is LaserGRBL notation. And this is actually fairly simple. Now, these X and Y's, they are basically referring to the actual project which is loaded in the canvas. As you can see over here is this keychain from my channel. And so when you say left, when you say, for example, X left, that means move the X axis to the left of the project that is currently loaded. So this will basically move the X axis all the way to the left of the bounding box. So the rectangle that encompasses the entire project within it. And so, for example, when we see G1, which is a linear interpolation or simply a linear movement, now we are saying I want the y-axis to move to the top of the project that is currently loaded. And so that's the way it basically works. So when you see this, this is relative to the project that is currently loaded. So as I said, you can learn the syntax, or you can copy and paste the block of code and to just edit this part, or to simply create your own. Now, in this particular example, I want to show you how we can add a very simple testing file. And so I want to create a simple 20 by 20 millimeters square, which we can use to test the machine. And so without having to actually load the file each single time. Now, to do that, you will just right-click, add custom button. Now, we want this to be a button because it's something that has to be executed, and that's it. Now, what we can do here, if is in this specific example, block of code that is a test file, we can basically generate the G code out of our vectorial editing software, for example, Inkscape, and then to come over here and to simply paste in the code that was generated. And so this is actually the square that I was talking about. It's a 20 by 20 square. There are some parameters here already settled. And so this is pretty much ready. The only thing is that since it is a test file, each time you want to test this rectangle on your material, you will need to set your power and speed. And so here you can see next to the G1, Y20, you have the S. Usually next to the S you set the power, and next to the F, the feed rate, you set the speed. And so if I want, for example, a 30% power, that would be 300, and 500 corresponds to 500 millimeters per minute. Now, the caption represents what is going to show below the image if you have an image. So in my specific case, I'll just write down test. Okay. The tooltip will represent the hint that is going to show up when you hover on top of it. And so in my case, I just want to remind to myself to set power and speed. All right. Now, when I want this to be enabled, well, I would like this to be enabled while the software is idling or the machine is idling, so without any project inside of it. And then I can also add my custom image, which I've prepared over here. So 20 by 20, open that up. So when I'm happy with this, I can just give on OK. And as you can see, my test file is over here. Now, sure enough, if I click on the test file, you will see your machine actually performing the engraving. And once it's done with that, it's basically all over. And this is pretty much all about custom buttons. Let's now quickly go over to the settings. Now, if you go over to the GRBL tab over here, you have two types of settings. Now, settings correspond to the settings of the software itself, and GRBL configuration represent the settings of your machine. Now, let's go quickly to the settings of the software. Now, I don't want to go over each one of them, also because you will barely need all of them, especially if you are buying a ready machine from manufacturer and not willing to build it yourself. And so some stuff that is worth knowing from the protocol, I think nothing apart from GRBL, which is the firmware type that most of laser engravers are running on. Now, under raster import tab, you can set the support for PWM, which is modulated power. So this is actually an option available on most newer laser engraver. But if you have an old laser engraver from a few years ago, most probably this option won't be available. Now, if you're following my channel, I've been explaining what is a PWM. How it works. So that's basically creating this power modulation, or in other words, variable power. And so it's allowing you to create grayscales. In older laser, this option is not existing. You only have a constant power. So for example, you say you want the power 30%, that's it, 30% constant throughout the stroke. Now, something else that you can change here is unidirectional engraving. Now, by default is not selected. That means that if you are engraving an image, for example, the laser will basically engrave in one direction and then also on the opposite direction. So when it's scanning through your project, it's going back and forth, and in both directions is engraving. So if you don't want that for some particular reason, you can check that out. The other thing is the resolution, or the lines per millimeter. Now here you see also the description of what each one of them are. So if you're interested, or if you don't remember, you can simply refer to that. So by default you have 20 lines per millimeter as a maximum number of lines, but if you want to have a higher resolution than that, then you can basically click on high resolution filling. Now this obviously will depend on the actual spot size of your laser. So for most laser engraver, this is more than enough. But if you want to go crazy, you can try that out. Then you have the disable G0. Now G0, it's basically free movement when the machine is not engraving. And so, for example, jumping from one engraved region to another, it will basically be in a G0 mode. Now, G0 uses the fastest speed of the machine, or at least the speed that is settled. I will show you in a while in the GRBL configuration settings. So the problem with that is that if the speed is too high, you might end up with not good results because you might overshoot a little bit. It's, I mean, lacking of precision. And so if you want, you can disable that, and you can then set, as you can see here again in the description, some of the speeds on the GRBL configuration. Then you have disable boundary warn. So basically, if you load a project which is larger than the engraving area of your machine, which is settled through the GRBL configuration, again, I'll show you that in a while, then you can basically disable that if you don't want that to happen. All right, then under vector import, there is not much there. Smart Bezier is just an optimized algorithm when importing raster image. Jog control. Now here, you know that when you click here the buttons, the laser is going to move at the speed settled from this slider on the left, and at by the amount settled on the slider on the right. Now, if you want, you can use a continuous jog. That means that you click as long as you hold down the buttons, then the laser travels. Okay, and so that will allow you to be actually quicker in a certain way. The other thing is here, for example, the click and jog. So if you double click anywhere on the space, you will see that the laser basically moves in that direction. Actually, I can show you that straight away. So if I double click here, you can see that the laser moved straight away there. So back to the settings. Then automatic cooling. So if your laser is having some thermal problem, you can enable auto cooling. This will basically pause a little bit the machine from time to time in order to avoid higher temperature. Okay. Then under the G-code tab, here you can see header, multiple passes, and footer. So basically, this is actually very interesting because you can tell the software to include a certain steps to be done before the project starts, while going from one pass to another, and then once the project is completed. And so as you can see here, it's setting the G90, which is using the absolute coordinate system. Luckily, there is also a description here, so it makes it very simple. And then at the end, it's going back to the origin. Again, there is a comment. And then multiple passes. For example, if your machine has a Z-axis, you might want to lower down the Z-axis by a certain amount, and so you can do that. In fact, it's written in a comment, uncomment this if you want to sync the Z-axis, so you will need to remove these semicolons here, and then the block of code is going to be executed. Finally, under the notification tab, you can see over here there are several sounds for certain action, like success sound, warning, error, connection, disconnection, and then Telegram notification. This is something new. If you want basically LaserGRBL to send you a notification on Telegram about stages and other stuff. All right, I'll close this up. Now let's go into the GRBL configuration. Now, this is basically, I can say, the heart of your machine. These are the configuration of your machine itself. So depending on the type of machine, you might have more or less stuff in there. Now, in my case, I'm showing you the configuration of the Neje Master 2S Plus, which is currently connected. Now, I won't go over all of them because you don't need them unless you're not designing your own CNC or laser engraver, whatever. So the most important ones are starting from position 92, see $22. So 22, it's homing cycle enable. Now, I've been receiving comments about, hey, what about the home button? I don't have the home button. Why is not there? So if your machine has a home, that means there are micro switches which determine the origin of the axis. Then the only reason why the home, this button over here, is not showing, it's because you don't have homing cycle enabled. Now this is a boolean, it means it's accepting only 1 or 0, or in other words, on or off. Now if I put this to 0, I double click and put this to 0 and write that down, as you can see my home button disappeared. And so to bring that back, I'll just need to set it to 1, write it, and now my home button is here, and you know what the home button is actually doing. Another common comment that I received is about the inversion of the axis. So some of you guys has been commenting that when clicking the home button, some of the axis is actually going on the reverse direction. Now this is actually very simple, so position 23. Now this one uses a mask value, doesn't matter what they mean. It basically will need to insert a value. In this specific case goes from 0 to 7, and each number represents a certain inversion. So in my specific case, as you can see, it's set all to 1. This is inverting the x-axis. So my machine had the x-axis inverted. But if you want to invert the y-axis, you will put 2. If you want to invert both the x and the y-axis, you will need to put down 3. And if you have the z-axis, you also have the option there, so you will go for 4 if you want to invert only the z-axis, 5, 6, and 7 if you want some combination of that. Then another important setting here is, there we go, the maximum spindle speed. This is the $30. And it's settled to 1000. Now, if you're wondering why it's called spindle, that's because G-code was primarily initially created for CNC routers, and so the spindle speed, so that's the speed at which the spindle, which is holding the tool, it's rotating. Now, in our specific case, this represents actually the power, and so the power goes from 0, as you can see on the minimum, to 1000. So that means that when setting the power, you have to multiply that by 10 in this specific case. So 1000, that means 100%. Now the other thing here is 32 is the laser mode enable. Now this is basically telling the software that we are actually using the software for a laser, and so because of the nature of the laser, which differ from a CNC router, there is no physical contact between the tool and the workpiece. You can basically have consecutive command be sent without having to dwell or wait anything to happen. Okay. Now another important parameters are the 100, 101, and 102, and these are the steps per millimeters or travel resolution. Now, the electric motors driving the axis in your laser engraver and also in many other CNC machine, they're called stepper motors. They're basically having steps, and so the software is basically sending impulses. Actually the board is sending impulses, and depending on how many impulses are sent, a certain number of steps are done. Now, depending on the driving system of your axis itself, like for example with a timing belt in most desktop laser engravers, you need a certain number of steps in order to physically travel 1 millimeter. And so for most desktop laser engraver, 80 steps per millimeter is the value, but in some specific cases, some manufacturers are using different driving system, different stepper motor, and so this might vary. Now, another common comment here from some of you has been why the dimensions are not in scale, or why the dimension along one of the axes is like shrunk or stretched. And now this is most often the problem. So the issue is that basically there is the wrong step per millimeter in there. And so a common way to see that, it's first of all just have a look if it's not 80. As I said, this is the most common value. Or if, for example, one is settled to 80 and the other one is settled to any other values. So most often they're equal because the same driving system is used for both axes. Or if they're basically mixed, you don't have any clue and 80 is not actually doing the right job, you can either calculate the steps per millimeter yourself, or you can simply search some manufacturer reference for your specific machine. And so this is something common. Then there are the last 3 sets of settings, and they are for all of the axes, XYZ, XYZ, XYZ. So you have the maximum speed here, maximum rate. So this is the maximum speed of the axis. So in this case, I have a 10,000 millimeters per minute, and this is also the speed that is going to be used for the G0 or free movement, in other words. Then the acceleration. This is the actual acceleration that takes from one speed to another, or from stall to the actual speed that was settled as a settings, as a parameter in your code. Now this is another common problem when you have engravings that are not coming right, or when you have the software throwing errors. So sometimes the value is too high, and so you will simply need to lower it down. And finally, you have the maximum travel. Now this represents basically your engraving area. And so as you can see, I have 255 times 420 engraving area in the machine. This is again the Neje Master 2S Plus. And so this is something that you might need to look at if you see that you have some problem, for example, with overshooting. Okay. Now, over here you have a refresh. Refresh is basically reading from the board in your machine. Write, if you do any changes, you will need to write so that the changes are sent to your board. And then the other thing that you can do is you can export these settings over here and to save that into a file, or you can import from a file, okay? And the file has an extension .nc or .gcode in this specific case. Now, I've exported the settings for my Neje Master 2S Plus, and they are available on my website, so I'll put the link in the video description below for your reference if you need them. I know that some of you have been using that and have been solving some of the problems, which actually is all about it. So if you encounter some problem, you can simply ask a friend or someone else with the same machine if they can kindly provide you with the GRBL configuration, and you're basically good to go. Now the very same thing can be done also on Lightbarn, but that's for another topic. But just for you to know, if you have any problem, just try to grab from somewhere or someone the settings for the same machine, someone that obviously doesn't have problem with their machines, and you are basically most probably good to go with that. All right, I think I've covered pretty much everything. Now there are some small new stuff in the software. I might think of covering that along the way with some additional add-on tutorial to this series. But for the time being, I think I've covered pretty much everything that you need to know in order to work with LaserGRBL. Now, if you have any comment, as usual, leave them in the comment section below. And I really hope you found this video and the overall series useful, helpful. If you liked it, click the thumb up button below, and do not forget to subscribe to my channel if you want to see more video like this one. Ciao for now!